Greetings to fellow panel and viewers. Welcome to Second International Postgraduate Conference on Mechanical Engineering. My name is Ashwindran Naidu, son of Chandrasekharan, a student from Faculty of Mechanical and Automotive Engineering Technology, in short FTKMA, UMP, University of Malaysia Pahang. Today I'll be presenting about a review on the prospect of wind power as an alternative source of energy in Malaysia. Since the presented manuscript comprises a wide range of topics, I have simplified the content into 7 elements, which is introduction, issues with wind turbine system, usage of fossil fuel, energy policies in Malaysia, wind condition in Malaysia, classification of wind turbine, and discussion. Introduction. Renewable energy is an alternative approach to depleting non-renewable energy resources. In response to increasing awareness to environmental issues, government and research agencies are providing support and resources to facilitate the growth of renewable energy sector. There are different types of renewable energy, namely solar, wind, tidal or hydromotion, nuclear and biomass. Today, wind turbines are the prominent form of renewable energy for direct energy harvesting. Technologies on renewable energy resources are sufficient and well developed on selected renewable energy systems. However, more extensive research and development is being conducted to improve the efficiency of the respective renewable energy system. For an example, Cognite stated that conventional wind turbine performs efficiently only at specific working condition. For example, angle of attack and aerodynamic characteristic of the blade, and also environment, wind speed condition, in which makes the wind energy conversion poor in general. Issues with wind turbine systems. Generally, conventional wind turbines are designed to operate efficiently at high wind speed ranging from 10 to 15 meters per second. This constrains the wind turbine to harvest adequate power at low wind speed condition. Sustainable amount of research is being conducted in effort of improving the conventional wind turbine, or in other words, design reconfiguration, such as blade configuration and morphology, rotor configuration, pitch angle variation, and others. Ikeda stated that conventional wind turbines work within the narrow zone center at different speed ratio at turbulent wind environment. Hence, limits the aerodynamic performance of the turbine. Moreover, Lee et al. Mentioned that wind turbines operate below atmospheric boundary layer, which is comparatively higher than inflow turbulence of aviation flight. The author also stated that interference posed by geographical obstacle in low wind speed region further increase the turbulent intensity. Hence, such environment creates unreliable wind flow conditions for the blade. Usage of fossil fuels. The politics and policies revolving around fossil fuel has encouraged greed among individuals on the control of power generation via fossil fuel. Chances on harvesting electricity from thermal-based fuel has become cheaper due to the extended learning process over the years on improving the harvesting process. Meanwhile, in Malaysia, high consumption of fossil fuel lead to high amount of carbon dioxide emission. Since 1980, there is continuous rise of carbon dioxide emission due to non-renewable fuel usage. United States Energy Information Administration, or in short EIA, reported that in 2017, Malaysia emitted 229 million metric tons of carbon dioxide due to high amount of non-renewable energy fuel consumption. Case in point, relative to Kyoto Protocol in 2002, the Prime Minister of Malaysia made a promise in reducing the carbon dioxide by 40% by 2020 in United States Climate Change Conference, UNCCC. However, Malaysian government has not taken any drastic steps in reducing the CO2 index. This can be seen by the rise of CO2 emission as shown in figure 1 from 2002 to 2017. Here is figure 1 on carbon dioxide emission by year in Malaysia, which is taken from EIA. Usage of fossil fuels. Unfortunately, at current status quo, Malaysia is strongly dependent on fossil fuel by 90% for electrical power generation. Although other countries are rapidly evolving into renewable energy resources, even as introducing the 100% renewable energy mechanism, where energy supply are entirely from renewable energy resources, several countries are involved in 100% renewable energy mechanism, where it's being analyzed relative to their energy supply and demand, which have presented comprehensively in the manuscript. Relative to Malaysia, restructuring renewable energy infrastructure and energy supply chain would displace the dependency of fossil fuel as the main domain of electricity supply. However, Malaysian government is still struggling in establishing a proper renewable energy power supply. Energy policies in Malaysia. Although several countries managed to develop sturdy and stable feed-in tariff mechanism on wind energy, Malaysia do still struggle on developing a robust feed-in tariff framework for wind power technologies. Unreliable political policies such as unattractive energy tariff rates, hike in land prices, and lack of financial support hinders the development of wind power sector. In 2011, Renewable Energy Act 2011 was formed, where the role of Act 725 is to stimulate the growth of renewable energy sector, where the Act is composed of comprehensive implementation procedure and information pertaining to feed-in tariff mechanism. Based on the effort and support given by local parties, it is evident that wind power harvesting is feasible in Malaysia. For an instance, realizing the prospect of wind energy during monsoon season, in 2005, Malaysian government installed 150 kilowatt wind turbine at Pulau Terubu, Layang-Layang, Sabah. Wind condition in Malaysia. Monsoon season occurs due to the influence of change in pressure and temperature. Since the pressure above landmass is low, in which causes to warm up the air faster in comparison to air over the ocean. Due to the difference in gradient, this causes the wind over ocean to blow to shore landmass. Studies shows that during southwest monsoon season, air temperature at Asian continent is higher due to low pressure, and in Australian continent is has low air temperature and high pressure environment. Consequently, this phenomena cause the wind to advert and convert to peninsular Malaysia and South China Sea. Northwest monsoon season influenced the wind speed to reach high speed margin due to the geographical region and weather phenomena. Some authors do claim that the wind speed during northeast monsoon season can reach up to 15.4 meter per second. Classification of wind turbine. Since wind speed intensity is qualitative description, which varies according to the benchmark defined by the local standard and geographical location. Moreover, this predicament has pondered manufacturers on wind turbine classification for product marketing purposes. Hence, for the purpose of wind turbine design classification, manufacturers adapted an international technical standard documented and proposed by International Electrotechnical Commission, or in short IEC, which is IEC 61400. Table 1 shows the classes relative to their wind speed and also category of turbulent intensity. Discussion. Although Malaysian researchers presented an attractive form of investigation or wind speed potential assessment, however, the methodology presented by the authors are highly doubtful and questionable, which I have explained comprehensively in the paper. This is due to the lack of crucial information on the methodology adapted for wind speed assessment. The wind flow pattern and intensity experienced by Malaysia is merely an after effect of weather change in neighbouring region. Nevertheless, it is found that selected region of East Coast Peninsular Malaysia and also region of Sabah and Sarawak is potential for harvesting wind power due to sustainable and adequate wind pattern behavior during monsoon season. Therefore, it is evident that geographical wind condition of Malaysia is appropriate for wind power devices such as a form of renewable energy in green energy sector of Malaysia. However, it is also found that fundamental design modification is required on conventional design of wind turbine in terms of blade morphology and configuration in order to adapt to unsteady monsoon wind speed pattern regions. Thank you for listening.